Lesson 4-1, Factors and Monomials, and in this lesson you learn to determine whether one number is a factor of another number. Let's take a look at this activity. Although it may seem like they're not all related, algebra and geometry are so interconnected that you can learn about algebra by exploring geometric figures. Two different rectangular arrangements of 12 squares are shown at the right. There are 6 possible rectangular arrangements of 12 squares. Use grid paper to draw the remaining 4 arrangements. So you can see here 2 possible arrangements of 12 squares, a 3 by 4 rectangle, okay, and a 4 by 3 rectangle, okay. So other 4 remaining arrangement to make 12 squares, okay, will be something like this. So this is a 2 by 6 rectangle, and this is a 6 by 2 rectangle. So this is a 2 by 6 because you have 2 as your width and length, and then 6 as your width, or you have 6 as your length, 2 as your width. The other 2 arrangements, okay, are a 1 by 6 rectangle, a 1 by 12 rectangle, and a 12 by 1 rectangle. Again, it makes 12 squares. So this is a 1 by 12 rectangle and a 12 by 1 rectangle. So those are the 4 possible possible rectangles you can make out of 12 squares. Again, let's write this. This is a 3 by 4 and this is a 4 by 3. And if you notice, they all have 12 squares. Okay? They're all 12, okay, in the figure. So you know that the 3 by 4, or 3 times 4 is 12, list all the pairs of whole numbers that have a product of 12. By just looking at the rectangle, it would be, okay, wait, not that one, right here, letter A, a 1 by 12, a 12 by 1, a 2 by 6, a 6 by 2, a 3 by 4, and a 4 by 3. And I just gave the answer for letter B. Compare your list, okay? Compare your list of whole number pairs to the length of the sides of the rectangles that you drew. What do you observe? They're all the same. Okay? So let's write a sentence about relationship between rectangular arrangements of squares and pairs of whole factors of of a number. Okay? You can see here, if we put it in a sentence, you can find the pairs of factors of a given number by using rectangular arrangements of that number of squares. Okay? So in letter D is just another way of doing this. Can you arrange 12 squares in rectangles so that one side of the rectangle is 2 units long, 3 units long? Okay? Did you know whether or not it could be done before you tried it? Okay, let's say you have 14 squares and it's asking you have 14 squares, okay, and you want to arrange them so that one side of the rectangle is 2 units long, the other one, and another arrangement will have another side of the rectangle which is 3 units long. The answer to the first question would be obviously yes, okay, because with that one you can get a rectangle that's 4 units long, meaning you can probably, let me find a rectangle for you, a 2 by 7 rectangle. Okay, so if I create a 2 by 7 rectangle, 2 by 7 rectangle, 2 by 1, 2, 3, 4, 5, 6, 7. That's still a rectangle. But if you notice, okay, the question 2, the answer to the second question, about 3 units long. There would be no rectangle wherein you can make one side 3 units and still make it a rectangle. Okay, so the answer to that question would be obviously no. Okay, now the answer to the third question, did you know whether or not it could be done before you tried? Okay, well, obviously you can, because if you look at this rectangle right here, you have a rectangle with 12 units. You know that you can divide 12 by 6 and get 2 without a remainder. Okay, and that goes to the same as 3 and 4. You can divide 12 by 3, uh, get 4 as your quotient without a remainder. Okay, and that goes the same with 14 squares. So what does that tell us? Okay, and let's bring it to our lesson for today, which are factors. So the factors of a whole number divide that a number with a remainder of 0. For example, 2 is a factor of 12 because 12 minus 2 equals 6. And 5 is not a factor of 12 because 12 divided by 5 will have a remainder of 2. Definition of a factor, you need to write this down. The factors of a whole number divide that of a number with a remainder of 0. Okay? So another way of saying this, another way of saying that 6 is a factor of 12 is to say that 12 is divisible by 6. Sometimes you can test divisibility mentally. These rules will help you determine whether a number is divisible by 2, 3, 5, 6, or 10. So the divisibility rules that we will enumerate down here will give us a faster way of knowing if a number is divisible by 2, 3, 5, 6, or 10. Okay? And these are the rules. A number is divisible by 2 if the ones digit is divisible by 2. Okay? Basically saying, if it is even, okay, it is divisible by 2. And obviously an odd number is never divisible by 2. So if it's even, it's divisible by 2. If it's odd, it's not divisible by 2. The next divisibility rule, a number is divisible by 3 if the sum of the digits is divisible by 3. A number is divisible by 5. If the ones digit is either 0 or 5, it's divisible by 6 if it's both divisible by 2 and 3. And a number is divisible by 10 if the ones digit is 0. Okay, let's apply these rules to example number 1. In example number 1, it's saying determine whether 146 is divisible by 2, 3, 5, 6, or 10. Let's look at 2. Is it divisible by 2? Obviously, it is divisible by 2 because first and foremost, 146 is even. Okay, and if it's even, it's always divisible by 2. Okay, is it divisible by 3? The answer would be no. Why not? Because if you add the digits together, 1, 4 plus 6 is 11, and 11 is not divisible by 3. Is it divisible by 5? Again, the answer is no, because the ones digit is not 0 or 5. Is it divisible by 6? The answer again would be no, because it's not anymore divisible by 3. Okay? And is it divisible by 10? Answer is no, because it does not, the ones digit is not 0. Okay, to verify your answers, you simply have to get a calculator and divide 146. Okay, if you get a decimal answer, it's not divisible by that number. So the only number that is possible would be 2. 146 is divisible by 2. So as the okay, I think it's on the next page. As the rules for divisibility suggest, a pattern can be found in many numbers that share factors. Looking for a pattern can help you determine other rules of divisibility. Let's take a look at example number 2. Look for the pattern in the digits of numbers to write a rule for determining if a number is divisible by 4. Just like any word problem we explore, we know a rule to determine if a number is divisible by 2. Okay, we need to find a rule for numbers divisible by 4. Okay, plan, let's use a calculator to determine many numbers that are divisible by 4. Then look for a pattern among those numbers. And let's take a look at this table. Since 2 is a factor of 4, any number divisible by 4 must also be divisible by 2. I hope that makes sense. Again, since 2 is a factor of 4, any number divisible by 4 must be divisible by 2. So let's look at some even numbers. Okay, and let's look at the last two digits of those even numbers. So 16, obviously, the last two digits would be 16. Is that divisible by 4? Yes, it is, because 16 divided by 4 is 4, remainder 0. So that is divisible by 2. Okay, oh, sorry, by 4. And let's say, take a look at 28. Okay, if we look at 28, it is divisible by 4 because 28 divided by 4 is 7. So our answer would be yes. These are all mental. So I hope you know how to divide still. Okay, and let's take a look at 112. And let's take a look at the last two digits of 112, which is 12. And we know that 12 is also divisible by 4 with a remainder of 0, and that would be a yes. Let's take a look at 148. It is still divisible by 4, okay, because 48 divided by 4 would be 12. Okay, so remainder 0 again, that's still a yes. Let's take a look at 254, and 254 divided by 4 will not garner a remainder of 0, so therefore the answer would be no. Okay, same if you look at 284 and look at the last two digits, 84, if you divide that by 4, you won't have a remainder, so the answer would be yes. Obviously, the last two digits of 1016 is 16, the answer would be yes. Okay, 2026 or 2026. Okay, last two digits is 26, and if you get it, get a calculator and divide that by 4, the answer would be no. Okay, so do you see a pattern in the divisibility rules? What it's saying is this: in all of the numbers that are divisible by 4, the last two digits form a number that is divisible by 4. For example, in 112, 12 is divisible by 4. In 254, 54 is not divisible by 4. So neither is 254 divisible by 4. So a possible rule for determining whether a number is divisible by 4 is that if the last two digits of a number are divisible by 4, then the number is divisible by 4. And let's conclude then, according to the rule, 524 to 816 and 1248 are all divisible by 4. Okay, because by using a calculator, we can check that our conclusion here is correct. That if a number's last two digits is divisible by 4, the entire number is divisible by 4. Okay, and being able to determine whether a number is divisible by another number is useful skill that can be applied in everyday tasks. Okay, let's take a look at example 3 and see how that works. In the Gregorian calendar, each common year is 365 days long. Okay, years are divisible by 4 called leap years are 366 days long. Also, years ending in 00 that are divisible by 400 are leap years, and those that are not are common. Okay, so determine whether 1998, 2000, 2066, and 2116 are leap years. Okay, let's read how they are leap years again. Years that are divisible by 4 are called leap years, 366 days long. Also, years ending in 00 that are divisible by 400 are leap years, and those that are not are common. Okay, so let's find out if 1998, 2000, 2066, and 2116 are leap years. 1998, is it divisible by 4? Let's take a look at the last two numbers. 98 is not divisible by 4, so therefore is it a leap year? The answer obviously is no. 2066. Okay, again, 66 is not divisible by 4, so again, this is not a leap year. And if you look at 2116, let's take a look at the last two digits, which is 16 divisible by 4. Therefore, that is a leap year. Okay, and let's take a look at the last one, the year 2000. Since 2000 ends in 00, it must be divisible by 400 to be a leap year. And then we get 2000 divided by 400 is 5, remainder 0. So 2000 is considered to be a leap year. Okay, so the years 2000 and 2116 are leap years, but 1998 and 2066 are not. Okay, let's see a connection to algebra here. We know that 5 and 12 are factors of 60 because 5 times 12 equals 60. Remember the definition of a factor. Consider the algebraic expression 5x. Since this notation means 5 times x, it follows that 5 and x are factors of 5x. Okay? Now, after knowing that, we now define what a monomial is. An expression like 5x is called a monomial. Definition of a monomial is an integer, a variable, or a product of integers or variables. Okay? So a monomial is an integer. Highlight that, write that down. An integer, a variable, or a product of integers or variables. Okay? So other monomials are z because it's a variable, 16 because it's an integer, mn because it's a product of variables, and 6ab it's a product of integers and variables. Okay? Expressions like 4x minus 2 and x plus 3 are not monomials. Why? Because they involve addition or subtraction. So remember, when you talk about a monomial, it only talks about the product. If it has addition or subtraction in the expression, it is not a monomial. Let's take a look at example number 4. Okay, determine whether each expression is a monomial. 5 times the quantity x plus y. Okay, again, that addition, okay, that addition operation prevents this from becoming a monomial, so this is not a monomial. And in letter B, if you notice, negative 25xyz are all product or are all being multiplied. Okay, so it's a product. This expression is a monomial because it is the product of integers and variables. Okay, and that's it for this lesson. Thank you.